And now a conversation with Amos Winter, founder and director, MIT Mobility Lab.
Amos, welcome to the show.
Thanks, Rich.
Tell everybody a little bit about your background, since you're going to be one of our youngest people interviewed.
I'm a gearhead engineer through and through. In 8th grade, in my graduation, I said that I wanted to go on and study mechanical engineering. And in my high school yearbook, I said I want to make underwater robots, when I become an engineer. And so I've kind of done all those things. As you said, undergrad, master's, and this summer, PhD in mechanical engineering. And I view my interest in engineering as solving design problems where your environment imposes constraints.
And where'd you develop this interest for mechanical engineering?
I was the type of kid that played with Legos and took stuff apart my whole life, and I still do. On weekends, take apart cars and fix cars. And yeah, I like tinkering. I like learning what other mechanical engineers were thinking when they designed something by taking apart their devices.
And then you've come up with some invention, which you think is going to help the world, right?
Yes.
So tell me a little bit about the process. How did you come up with an idea, and how did you decide on the idea you have?
So my idea, the invention, is called the Leveraged Freedom Chair, and it's a wheelchair that I'm developing specifically for use in developing countries. And why I started thinking about this was I spent a summer in Tanzania looking at wheelchair technology. I did a survey for a group in the US and a group in Tanzania, trying to find out what products were being used, how well they were meeting people's needs, how repairable they were, how accessible. So I spent a summer talking to wheelchair users, wheelchair manufacturers, and disability groups throughout Tanzania. And through this firsthand experience with people with disabilities in a context like that, I saw that existing products don't fully meet people's needs. A person with disabilities in a developing country may have to go 2-3 miles a day in order to get to school or a job, and may have to travel on rough dirt roads under their own power to get there. And you try doing that in a conventional wheelchair, it's basically impossible. So I came back, and over a few years, came up with this idea for the Leveraged Freedom Chair, which is a single mobility aid that you can go long distances on rough terrain, but is also small enough to use in your house like a normal wheelchair.
So what are the major obstacles you've encountered to get to the point you are today?
The biggest obstacle is coming up with a technology that's going to be appropriate for the country in which you're working. We're under huge constraints in materials that are available, the types of terrains that this thing's going to ride on, the price at which we could sell the chair. So the point of innovation, that real aha moment of invention, was realizing how we can make a machine that's mechanically very simple, but that can ride a bunch of terrains, a real wide range of terrains efficiently. And that's through the lever-powered system that we have. So that lever system is built all out of bike parts that you can buy anywhere in the developing world for $1 per pound. It allows us to make the chair so it can be sold for about $200, which is the exact cost of existing wheelchairs sold in developing countries. And because every moving part is made of a bike component, you can repair our chair literally anywhere. So I think it will be very much a back and forth in finding technical compromises and financial compromises to get a product out that's low enough cost that it's going to be competitive, but high enough price that we can actually use some of the profits to help, mobilize people throughout the world. I would say if you have a good idea, partner up with somebody who can help you get to where you want to go.
What are the next steps now for you?
During this whole process, we'll develop the tooling and fixturing to produce the chair at a large scale. And then hopefully I'll be in India next year working with the largest disability group in the world, Jaipur Foot, finishing up the project, doing the production tooling, finalizing any design changes, finalizing jig designs, and doing a trial of 100 chairs throughout India. And then at that point, hopefully we'll have a product that we can give to any wheelchair workshop anywhere in the world, and they can make it as an open source technology.
This is fantastic because you're looking at a double bottom line on this. What is the social impact? And there might be a commercial idea where you actually could make some money from this as well. Earlier you talked a little bit about social entrepreneurship, and we're all recognizing now globally and in the United States that social entrepreneurship is becoming an expanding phenomena. I'd like you to talk a little bit about your generation. What motivated you to get into social entrepreneurship? What's the culture like at MIT, and what are you seeing within other people of your generation that are also interested in social elements of entrepreneurship, not just creating the next YouTube or Google?
A message I try to convey to the undergrads I teach is that you can sit at home and solve set problems out of a textbook, but you don't have any connection back to the real world. And when you take a class related to international development or social entrepreneurship, you see firsthand how your technical skills can be used to affect positive change in the world. And that's a tremendously compelling lesson for students. Well, I got involved by accident, really. But I spent a summer abroad, and I saw this problem firsthand. And so what went through my mind was, I'm a machine design engineer. You know, I have, a great pedigree, I guess, in this background. And I'm in this great position to do something about it. I can make a better wheelchair. I'm well qualified for that. And I can go back to MIT and rope in 20 undergrads and help them, or get them involved too. So
your labor costs are good, right?
Yeah, we work for free. Yeah, we can kill anybody else on a grant proposal because, we're not paying salary or benefits or anything. But that was a really powerful lesson for me. I had worked in conventional high-tech type engineering, and it's cool technology. I'm a total geek, and I like that. But then on top of that, you get this feeling that here's this person literally crawling on the ground and being shunned by society. And if they can wheel themselves around and get into school, now they're becoming a real participant of their community. That's a tremendously powerful lesson.
And another element of your socio-entrepreneurship is it's international in nature.
Yeah.
So what about the barriers and the challenges in working with a lot of other countries, and especially developing countries, with trying to bring forward a new idea or concept?
That is a big barrier, because it's absolutely imperative that you work with community partners when you do international development technology, because you can come up with the greatest idea, but when you bring it abroad, if it tastes bad or looks weird or costs 10 cents more than it should, it won't get adopted. And it's really through that first-hand interaction with your stakeholders that you learn about those things. And for me, this is critical in wheelchair design, because we all the time we think, oh, we came up with the best solution ever, and we'll get there and they'll say, oh, this little thing is wrong, and it prevents me from using the chair indoors, for 10 hours a day. It's a huge problem. So we benefit so much from that interaction, and I like to think too they benefit so much by having these first world engineers come in, and work on this type of technology. I really believe in that collaborative partnership where both of us now, leveraging each other's skills, can do something that neither of us could do alone.
So Amos, I understand we have a leveraged freedom chair with us today.
Yes, and
Let's take a look at it.
Show it to you. So it's right here, and right now the levers are not in the chair, and you can use it just as a regular wheelchair. It has the cushioning and postural support for what's required of a wheelchair, and it's balanced like a wheelchair, so you can pop the front wheel over obstacles. And indoors, you'd use it like a regular wheelchair, just with the push rims. When you want to go long distances, say you have to go to school or something, you can take the levers out, and they stick into these couplings, and you propel yourself by pushing forward on the lever, and it ratchets back, and if you need to brake, there's this little bar here, you pull back and it rubs against the wheel, and that provides the brake. The whole trick behind this machine is that to effectively change gears, all you do is put your hand at different positions on the lever. So if you need to go through mud or something, you grab high on the lever, you produce a lot of torque at the wheel, and you can muscle your way through anything. And as you want to go faster, you slide your hand down, and so every push you go through a larger angle and create a faster rotational velocity in the gear train. So because all the mechanical complexity of the machine is accomplished by the person shifting their hands, the machine itself is very, very simple. It's just a single speed bike drivetrain that we make out of parts that you can get anywhere for $1 per pound. So you can make and repair this wheelchair absolutely anywhere. You can go to mlab.mit.edu and you'll see the page for this chair.
Thank you very much, Amos.
Yep, thank you.